pre-training thermal building control reinforcement learning agents. So what it is about, buildings contribute up to 30% of global energy consumption and 27% of global CO2 emissions. Reinforcement learning can reduce this energy consumption. However, you can't directly train the reinforcement learning agent in the target building, as this would lead to extreme conditions in the target building. So people often use physical building models to pre-train the reinforcement learning agents before deployment. However, this is not scalable. So what to do? The first idea is to use data-driven surrogate models which replace the physical building model for reinforcement learning pre-training. However, you need lots and lots of target building data to accurately approximate the building thermodynamics. And the second idea is to use generally pre-trained source models, which have seen a lot of building thermodynamic data, and fine-tune that to the target building, but with very little data of the target building to get this approximation. So what did I do in the poster? I combined the generally pre-trained data-driven models with transfer learning to create building surrogate models with very little target data to pre-train the reinforcement learning agents, but now in a scalable way. I had two specific questions in mind in the poster. So how does increasing the variance in this generally pre-trained source model affect the later on reinforcement learning performance? And also, do longer fine-tuning periods to the target building positively affect the reinforcement learning performance later on? So it turns out, actually it's not that easy. The overall approach worked to some extent with this transfer learning based surrogate model for reinforcement learning pre-training. However, more variance in the generally pre-trained source model and also longer fine-tuning periods to the target building didn't actually improve the reinforcement learning performance that much. So in the end, actually have more questions left than in the beginning. For example, how can I better cover the state space with the generally pre-trained model? How can I better fine-tune to the target building, as especially the target data is influenced heavily by the controller of the target building? And in the end, how can I better capture the impact of the control variable to the building thermodynamics and with the surrogate model, as this is the most important thing for the reinforcement learning pre-training loop? And hopefully I see you at my poster later on for the discussion of these questions. 229, I think.
All right, thank you. And now this brings this session also to a close. I hope you have enjoyed the talks. Thanks again to all.